The screen is visible, right? Okay, so hypothesis. Why do we need this testing of hypothesis basically? So we colored like for example, let us take the COVID vaccines. We found out many vaccines and we had to test them on. We had to like test them before we like give it to public use. So we test them on specific peoples, like say different peoples, and then we collect the data on how this vaccine works, and then we set say a specific threshold or a specific condition. If the vaccine meets that condition, then it will be allowed for public use, else it won't be allowed. So we basically need to like test our assumptions on whether this vaccine is working on whether this method is effective and so on. So for that we need testing of hypothesis. So what is population? Population is basically a large group of objects or people on whom we are going to conduct the experiment and get data from. For example, if we are let us the let us take the example of COVID vaccines itself. We'll like collect we'll ask different people from different regions to participate in that, and the collection of the people who come to participate is population. Sample is a small subset from that population. uh, Using this sample we test the hypothesis, and then we can basically represent the population, like this subset represents the whole population basically. Number of objects or people in a sample is called as sample size. If the sample is less than 30, then we call it a small sample. If sample size is greater than 30 or equal to 30, we call it as large sample. Parameters, like for example, to analyze a data set, we use para many measures like mean, variance, and so on. This is called as parameters. If the mean, variance, etc. are based on the population, it is called as like parameters. Or if it is based on the sample, it is called as statistics. For parameters, it is denoted by Greek letters, and for population, it is denoted by the Roman letters. Okay, so statistical hypothesis. Okay, so statistical hypothesis is basically us making an assumption based on the population parameter. Let's say, for example, we assume that the vaccine is working basically, but while we conduct the actual test and then we get the data, we will come to know if the vaccine is already working, that is our assumption was correct, or if the vaccine is not working. A hypothesis is our assumption at first, that the based on the data set. There are two types of hypothesis. Null hypothesis, it means that there is no change. That is our initial hypothesis, the initial assumption we made. In the vaccine case, it is like that the vaccine is effective and it is working. Alternative hypothesis is any hypothesis that is complementary to the null hypothesis. For example, if the vaccine is not working, or if number of people who like respond to the vaccine in a positive way are less than the expected mean, and so on. It is called as alternative hypothesis basically. So how do we generally make hypothesis? In our case, we assume hypothesis to be a population mean will be given. This is the population mean. We assume that population mean does not change. Or for alternative hypothesis, we take three cases. That the population mean is not equal, that is the population mean changes, or a population mean is less than the mean we assume, or population mean is greater than the mean, we assume. Basically, this is called two-tailed test. For this we use two-tailed test. For this we use one-tailed test. Our test methods vary on what is the alternative hypothesis we are choosing. Here, for two, each method has each way of doing. For mu is less than mu naught, we use left tail test, and for mu is greater than mu naught, we use right tail test. How does it basically work? Like, uh, so for example, if we take h is not equal to h naught, it will be two tailed. So we draw a normal distribution curve, the bell curve, and then there will be a z value for each level of significance. I'll say what is level of significance now. For example, let's assume it is 0.05. So there will be a value of z here, which is 1.96. So we'll calculate these z values using the parameters which is given to us. If the z value lies anywhere in this area, then it will be rejected. The null hypothesis will be rejected. Or if the z value lies between minus 1.96 to plus 1.96, then it will come in the area of acceptance. So we'll accept the null hypothesis and then reject the alternative hypothesis. That is, our assumption was correct at the beginning. In case of, sorry, it should be mu not equal to mu not, my bad. In case of mu less than mu naught, it will be one tail, more specifically left tailed. So for left tail, we'll draw the standard bell curve, and then we'll assume level of significance to be 5%. So for 5%, the value of z is 1.96. So this will be the area of reject. This will be basically area of acceptance, and here will be the area of acceptance. So accept our we'll accept our null hypothesis if our value of z is greater than minus 1.96. Similarly, for mu greater than mu naught, that is one-tailed, right tail to be more specific. We'll draw the bell curve again, and then we'll calculate the value of z using the level of acceptance and the parameters. So this will be the area of acceptance. So basically, if our z value is less than 1.96, we'll accept our null hypothesis here. Otherwise, we'll reject h0 and then we'll accept h1. So errors in sampling. So what is errors? Till this, is everything okay? Is there any doubts? Hello? Should I take this again? Is this okay for everyone?
It's fine. Come.
Yeah, okay. Okay. So basically, what is errors in sampling? Errors are like we assume something and then we just work on the data set. Sometimes it may, almost all the times it will be correct, but sometimes it can be incorrect. For example, h naught may not be true, but we will accept h naught according to the data we get. Otherwise h naught might be true, but we have to reject h naught according to the data we get. So that is called as errors. There are two types of errors, type 1 error and type 2 error. Type 1 error is basically when we reject h naught even though we know it is true, and type 2 error is when we accept h naught even though when we know it is false. That is, we know that the alternative hypothesis is true, but we will have to accept h naught. That is called as type 1 error and type 2 error. Type 1 error is also called as producer's risk, and type 2 error is called as consumer's risk, as it is given here. So type 1 error will be represented as alpha and type 2 error will be represented as beta. Here, the level of significance is alpha. That is, the probability of the type 1 error occurring is basically alpha here. So alpha can be 5%, 1%, or 10%. That is the this is basically the probability of us rejecting h naught, even though h naught is correct and h1 is wrong. So this is the level of significance. How do we generally test the hypothesis? First, we set the null hypothesis and then we set the alternative hypothesis. Using this alternative hypothesis, we decide if it should be one-tailed or two-tailed, and then we select the level of significance which will be given to us in the question. If not given, we usually take default level of significance to be 5%. And then we have to compute the test statistics here. That is, we'll substitute the value of z for large sample and small sample. There are separate formulas for that. And then we'll compute the value of z, compare it with the value we have as with the standard values for each significance. And then if the value we dot lies in the area of acceptance, we accept h naught, else we reject h naught. So table value for large sample test. For large sample test, we use a normal distribution that we used in continuous random variables. For a small sample test, we use t-table distribution. For large sample test, there are some standard values for z is equal to 5% and 1%. Suppose if you forget it, how to find it? Like, we know the level of significance is the probability of error occurring, that is 0.01. From this, we have to subtract 0.5 so that we get this area. As we know the symmetric property of curve, 0.5 minus 0.01 will give us 0.4, sorry, 0.49. And then from this, we have to backtrack in the normal distribution table, which will be given to us in exam. When we backtrack in it, we'll get the value of z to be 2.58. Like, it is better to know the standard values for z for 5% and 1%. Suppose if you forget, you can use this method to find the value of z in exam. uh, okay, why does this and this differ? Basically, here z is 1.96, but here it is 1.645. Why? Since for here will be taking this whole value, so it will differ here. Here will be taking this and this area alone, so it will be different here. Is this okay? I'll think that it's okay and then I'll move on. Okay, so degree of freedom. What is degree of freedom? Degree of freedom is usually for small sample, that is uh, n less than 30, less than or equal to 30. Can say that. That is n less than 30. Degree of freedom usually refers to the number of uh, objects in the sample that can vary such that it won't affect the overall hypothesis. For example, if I take the mean of three numbers, say 8, 12, and 8, 12, and 4. So we'll get the numbers to be as 24. 24 by 3 will give us 8. For example, I can vary these two numbers to, like, say, I'll vary this to 10 and then I'll vary this to 10. I can vary these two numbers and I have to keep this number same to get the same value of mean. That is, in these three numbers, two numbers can change. According to it, one more number will be fixed. This is called as degree of freedom. Here, the degree of freedom for this sample is 2. So the formula for degree of freedom is n minus 1, where n is the sample size. So large sample. For a large sample means n is greater than 30. How to test? For large sample, we use standard normal distribution that we learned in unit 3. Okay, so how this is the formula for finding the value of z to test it accordingly. Here x bar is equal to sample mean, mu is equal to population mean, sigma will be population, sorry, sample standard deviation. This is standard deviation, this is not variance. Variance will be sigma square. This is standard deviation. And n will be the sample size. Similarly, suppose if we are not given the sample standard deviation, then we can use S. S is the population standard deviation. Okay, so confidence limits. What are confidence limits? Confidence limits are basically the value of mu such that, suppose while we are testing a sample, we get the value of mu, and this we get the value of z, and from this z we are going to accept h naught. So confidence limits tells us the value of mu, uh, tells us the uh, uh, how to say, like, tells us the boundary, or the, okay, we'll take it as boundary, tells us the limits for mu. That is, if mu lies between the values we are going to compute, then it will, then the we can still accept h naught. If mu varies, okay, so basically, for example, x bar plus or minus 1.96. This is the confidence limit for 5%. 95% means 5% confidence limit. Alpha is equal to 5%. If mu varies between the answer we get from these two, then we can accept h naught. If mu does not vary between the answer we get from these two, for example, if we get the values 1 and 2 here, just an example, if mu varies between 1 and 2, then we can accept h naught. Else, if mu varies from any other value from 1 or any other value except for this boundary, then we will have to reject h naught, which is basically confidence limit. Mm, till now, is this okay? Mm, okay, so this is for single mean. Till this, it was for single mean. Single mean means only one sample is given, and then we are going to consider only one sample. Difference in means means we are taking two samples, or we are taking two populations. We are taking two populations. For example, let's take the case of COVID vaccines itself. We can consider population 1 to be the vaccine tested in India, and population 2 to be the vaccine tested in some other country. So we'll get the data from both the countries, and then we'll check if it's working, and then we'll conclude accordingly. That is called as difference of mean. So the formula will be z is equal to h1 bar minus h2 bar divided by sigma 1 square plus n1 plus sigma 2 square by n2. We won't be using mu1 and mu2 in this formula. Why? So basically our null hypothesis here will be mu1 is equal to mu2, and our alternative hypothesis will be mu1 is not equal to mu2, or mu1 less than mu2, or mu1 greater than mu2. This will be our cases. So if we actually the formula will be z is equal to h1 bar minus h2 bar minus mu1 minus mu2 by sigma sigma 1 square by n1 plus sigma 2 square by n2. Since our null hypothesis is that mu1 is equal to mu2, so this whole term will become 0. So our z formula is this. There are three cases in this. If sigma 1 is equal to sigma 2, then this will come out and it will become this formula. Z is equal to x1 bar minus x2 bar by sigma into 1 by n1 plus 1 by n2. If z1 and z2 are not given, and only sample standard deviation is given, then we can use this formula. Or if then we can use this formula, substitute and get the value of z. In this case itself, otherwise we can substitute the value of sigma using this formula. We'll see it in the sums now. So far, is it okay? Okay, so I have some sums here. Okay, for large sample single mean, the formula, like I said, x bar minus mu by sigma by root n. This is the standard deviation of population. Else, if standard deviation of sample is given, we can use this formula. Confidence limit, in general case, confidence limit will be x bar, which is the sample mean, plus or minus the value of z at the given confidence level, or the given level of significance. This is level of significance. And this is the z value corresponding to the level of significance divided by sigma, which is standard deviation of population, by root n, which is the sample size. So we'll see the first question and fourth question now in this problem sheet. The first question. So basically we have a sample of 900 members. N is equal to 900. Okay, so N is equal to 900. A mean, a sample mean is given to be 3.4 centimeter H bar, and then the standard deviation is given to be 2.61, that is S. And then the population mean is given to be 3.25, and then the population standard deviation is given. We have to test that 5% level of significance, and then we have to find the confidence limit for 5% and 99%. That is 5% means alpha is equal, 95% means alpha is equal to 5%, and here 99% means alpha is equal to 1%. So I have written the parameters, the given over here. From this, we have to find the confidence limits, and then we have to find the hypothesis at 5%. So first we have to write the hypothesis. Here they didn't ask us if it is greater than or less than or anything like that. They have just asked if it is valid or not. They have just asked us to test. So it will be generally it will be two tail unless and until we get any keywords like maximum, minimum, increase or decrease. So we'll write the hypothesis, that is mu is equal to mu naught, null hypothesis. So mu is equal to 3.25. That is the population mean. And then mu is not equal to mu naught. That is our alternative hypothesis since this is two tail. And then we have to this is the formula. Since we have sigma here, we are using sigma itself in this. X bar minus mu into sigma divided by sigma by root 10. I have substituted and I got the value of z is equal to 1.724. For 5% level of significance, the value of z for two tail is 1.96. So if Z lies in this area or this area, we will have to reject H naught. If Z lies in this area, that is the level of acceptance, we will have to accept H naught. Since Z is equal to 1.4271 lies in the area of acceptance, we will accept H naught and reject or H1 or alternative hypothesis. So the second question is fourth question. The average number of defective articles per day in a certain factory is claimed to be less than the average of all factories. They claim it to be less than the average of all factories. Okay, so the average of all factories is given to be this. So this will be mu. One minute, I'll bring this here so that it will be easy. Mm, so I don't have the problem sheet for that, but I'll tell you what to do basically. 1 minute. Just it's there. Sorry, my bad. I'm so sorry. Okay. So for this question, we have to in the previous question we have to find the confidence limit also. I completely forgot about that. So take the value of z for 1%, that is 2.58 for two tail. Substitute the value of z and then mean is given to us x bar, that is sample mean is given to us. X bar substitute here and then standard deviation sigma is given here and then uh, n is also given here. Then should be 900. Sorry, should be 900. Substitute these values, simplify, and then you'll get two values of mu. So if our mu lies between these two values, then we can accept H naught at 1% level of significance. Else we'll have to reject H naught and accept H naught. Similarly for 5% level of significance. So here, as we can see, we have the keyword less. So less means one tail. And it depends on which we are choosing to be as mu and which we are choosing to be as mu naught. So we'll assume okay. Uh, so we'll assume the average number of in all factories to be as mu. Okay. So our first assumption is that for this the class for the certain factory is given here and then the number of days is given here, defectives and stuff. So we have to test that 1% level of significance. Okay. So we have mu here, which is the population mean for The population mean for all factories, and we have number of factories here. We have to find its sample mean, sample standard deviation, and then we have to row. And then the level of significance is 1%, that like is given. The hypothesis, we have to set the hypothesis. General hypothesis, h naught will be mu is not equal to mu naught, that is mu is not equal to 30.5. Here, since we have the keyword less, it should be mu less than mu naught. Since mu is less than mu naught, then it should be left tail. Since in the bell curve, uh, this will, if this is the mu naught, this will lie less than this will be less than mu naught, and this side will be greater than mu naught. So it should be left tail. In case we get mu greater than mu naught, which should be right tail, since this will be greater than mu naught, and this side will be less than mu naught. So how to find the standard mean and standard deviation for this sum? So this was the limit, this was the table that was given to us, and then we have to find h side, that is the uh, average of the lower limit and the upper limit. 18 will be 16 plus 16 plus 20 divided by 2, the average of these two. Similarly, for all the cases, we have to find the average of the lower limit and in the upper limit, and then multiply it with the number of data, that is fi over here, and then we'll get the value of mean, sample mean, and then similarly the value of standard deviation, sample standard deviation, we'll get it as 6.35 when we substitute in this formula. So z is equal to x bar minus mu by s by root 10. Substitute the values in this, and then we'll get the value as 2.6771. When we mark it in the graph for 1% level of significance for one tail, value of z is equal to minus 2.33. This is less than the value of z, that is minus 2.6771 is less than minus 2.33. So we'll accept, so we'll reject h naught and accept h1 as it does not lie in the area of significance. Is this clear? Are these two questions clear? Any doubts? So for all the other cases, I'll tell which tail we have to use. From that you can solve it. So n is given to be, n is given to be 900. A sample of 900 members is found to have a mean of 3.5. This is the sample mean x bar. Can it be reasonably regarded as a simple sample from a large population whose mean is real population mean is mu is 3.38, and population standard deviation is sigma, which is 2.4. We have to test that 5% level of significance. Since they did not give us any keywords like maximum, minimum, increase, decrease, less or greater than, and so on, this will be a normal two-tailed test. We have to substitute the given values in the value of z, and then we have to, for 5% level of significance, it is 1.96 for two tail, and then we have to check if the value of z lies in the area of acceptance, and then we can either accept a h naught, which will be mu is equal to 3.38, or reject a h naught, which will be mu is not equal to 3.38, h1, that is, or accept h1, which only mu is not equal to 3.38. And for the third question, uh, the mean of the manufactured population mean is equal to 1800, and population standard deviation is 100. Okay, sample of 50, that is n is equal to 50, sample size is 50, and it is uh, mean mean breaking strength is 1850. That is s- sample mean is given to be 1850. We have to support this claim at 1% level of significance. Alpha is equal to 1%. Their claim is that the breaking strength of the cable has increased. Since we have the word increased here, then it will be uh, one tail. One tail. Since it is increasing, it will be right tail. If they are given it as decreasing less than or minimum, it will be left tail. Since if they give it as increasing maximum or greater than, then it will be right tail. And then the fourth question is it. Fifth question is the sample size is n is equal to 100. Uh, Population mean is given to be 1570. And then the standard deviation is 120 hours. And then the population standard deviation is 120 hours. So if the and then for hypothesis they are given as the mean directly, that is mu is equal to 1600. Oh, sorry, my bad. This is sorry. I'm so sorry. This is sample mean and sample standard deviation. X bar is equal to 1570 and standard deviation S is equal to 120 hours. Okay. Uh, from this we have to this is the population mean. They have given us the hypothesis directly. Mu is not equal to 1006 hours. That is mu is not equal to mu naught. So it will be a two-tailed test at level of significance to be 5% and 1%. And then for sixth question, the sample size is 400. N is equal to 400. Sample mean is 99. That is H bar is 99. They're asking if test whether the sample could have come from a normal population with mean 100 and standard deviation 8. That is population mean is mu is equal to 100 and standard deviation is equal to 8. Population standard deviation is 8 at 5% level of significance. Alpha is equal to 5%. This is two tails since we don't have any like any keywords as increasing, decreasing, and so on. Is this okay? We'll next move on to difference of mean. So for difference of mean, okay. So the formula for difference of mean is z is equal to x1 bar minus x2 bar divide. This is the general formula. Z is equal to x1 bar minus x2 bar divided by sigma 1 square by n1 plus sigma 2 square by n2. X1 bar and x2 bar are sample means. Sigma 1 square and sigma 2 square are uh, population standard deviation. And then n1 and n2 are sample sizes. If sigma 1 is equal to sigma 2, then you can take this sigma outside and the formula will become like this. Suppose if they didn't give us sigma and they gave us only sample standard deviation, then we can use this formula. So we'll solve two sums in this. The first sum is two samples are given, difference of mean. How to find it? It's a difference of mean means they'll give us two samples, two data for two samples. From that we can find out if it's a difference of mean or for single mean. So one sample size n1 is equal to 500 and mean is found to be 20 h1 bar. N1 h1 bar, and another independent sample size n2 is given. The mean is given for this sample. But the samples have been drawn with the same population with a standard deviation for. They are given as sigma here, and then we have to test that 1% level of sigma. So first we have to get all the data which is written here. Then we have to make the hypothesis. For difference of mean, the hypothesis would be mu1 is equal to mu2, a null hypothesis. The alternative hypothesis will be mu1 is not equal to mu2, or mu1 is less than mu2, or mu1 is greater than mu2. So here they didn't give us any keywords like less than or greater than and so on. So it will be mu1 is not equal to mu2, which is two tail. Since the value of sigma is equal for both the cases, we can substitute the value of sigma in the formula. This formula will be using, since the value of sigma is common, we can substitute in here, we can get the value of z, and then we can draw the bell table, I mean the bell curve, and then we can check the value of z. Here z will lie somewhere over here. Z is equal to 18.6339. Since it does not lie in the area of acceptance, we have to reject h naught and accept h. In this case, accepting H1 means no, the samples do not have been drawn from the same population. Please write this conclusion also after the sum. Conclusion according to the given question. So next we'll see the fourth one. They have given us the data accordingly. Mean is given, standard deviation is given, a number of sample is given. This is H bar. This is sample standard deviation, and this is n. 5% level of significance. Alpha is equal to 5%. We'll take country N to be the first value, that is N1, and then country B to be the second data set, that is N2. So we have written all the values here. Since S1 and S2 are given and they are not equal, so we'll use this formula. Z is, first we have to make the hypothesis. Here the hypothesis states that random samples drawn from the two countries given the following data is given. Is the difference in standard deviation significant? They didn't ask us if there is any increase or decrease, or if one is greater than the other, or so on. So we have to just check if it is significant. That is, if mu1 is equal to mu2, will be a h naught. If it's not, mu1 is not equal to mu2, will be our alternative hypothesis. So since this is a hypothesis, we will have to use two-tailed method here. For two-tailed, sorry, we'll have to use two-tailed over here. Since S1 and S2 are given, we'll use this formula. Z is equal to x1 bar minus x2 bar divided by s1 square by n1 plus s2 square by n2. When we substitute the given data in this formula, we'll get the value of z to be this. Since for 5% level of significance, for two tails, z will be 1.96. Since 1.56 lies somewhere over here, we can accept H naught and reject alternative hypothesis. That is, yes, the difference between standard deviation is, no, sorry. Is there any significant difference, they have asked? So since mu1 is equal to mu2, there is no difference in there is no significant difference in standard deviation. We have to write this conclusion. So I'll tell for all the other questions also. The sales manager of a large company conducted a survey in states A and B, taking 400 to be samples in each cases. N1 is equal to N2 is equal to 400. So the results were in the following table. The results are given in this table. Test whether the sales is same in two states at 1% level of significance. Alpha is equal to 1%. They have just asked us to test if the sales is same. They didn't ask us if it is greater than or less than or something like that. So it will be mu1 is not equal to mu2. That is two-tailed. So x bars are given, x1 bar, x2 bar, and then S1 is given, S2 is given. We will have to use Z is equal to H1 bar minus H2 bar divided by root of S1 square by N1 plus S2 square by N2. We can substitute the given data in this formula, and then for 1% level of significance, we can take the value of Z, and then if it lies in the area of acceptance, we can accept H0, else we'll have to reject H0. This will be our alternative hypothesis. For a given mathematics text to 50 girls and 75 boys, the girls made an average rate of 76 and boys made an average rate alpha they have given. So basically, uh, okay, so they have given us 50 girls and 75 boys over here, and then they have given us the mean sample mean is also given to us. So we'll have to check. They have asked just the significant difference, so we'll have to check if mu1. So alternative hypothesis will be mu1 is not equal to mu2. That is two-tailed. Uh, so they have given us sample size, that is n1, n2. They have given to us, and then they have given us 1 minute. This confusion. I'll just check it once. So they have given us the sample size, that is n1 and n2. The girls made an okay, so n1 and n2 is given to us. They have given the whole thing in this. That is, they have given the whatever data is given in this. They have given it in the box. So n1 and n2 is given. Mean is given, x1 bar and x2 bar is given, and then standard deviation, that is s1 and s2 is given. Substitute in this formula, and then we'll get the value of Z. From this we can, since it is two tail, if it lies in the area of acceptance, we'll have to reject it, else we'll have to, I mean, if it lies in the area of acceptance, we'll have to reject H1. If it lies in the area of, if it does not lie in the area of rejectance, we'll have to accept H1, that is reject H0. So for fifth question, N1 is given and N2 is given. The members are the means. So H1 bar is given to us, and then H2 bar is given to us of the two samples, and then can the samples be regarded to be drawn from the same population? That is, if we'll have to check if mu1 is equal to mu2. H0 will be mu1 is equal to mu2. H1 will be mu1 is not equal to mu2. Two-tailed. Since we don't have any keywords over here, standard deviation is given to be same, sigma is given to be same here. So we'll have to use 5% level of significance, alpha is equal to 5%, and then the value of Z will be x1 bar minus x2 bar divided by sigma 1 by 1 plus 1 by x2. So substitute the given data in this formula, and then since it is two tail, we know the value of Z here 1.96. if the value of z lies between minus 1.96 to plus 1.16, then we can accept our h naught, else we'll have to reject h naught. And then for our sixth question, sample of heights of, we'll assume English meant to be as first sample, and then American meant to be a second sample. So N2 is N1 is given to be 6400, N2 is given to be 1600, H1 bar is 170 centimeter, and then standard deviation S1 is given to us. Similarly, H2 bar is given to us, and then the standard deviation S2 is given to us. What does it ask? It asks if the data mean that Americans are on average taller than Englishmen. That is, since we are assuming Americans to be mu2, we'll have to check if mu2 is greater than mu1. That is, if mu1 is less than mu2. So our hypothesis will be mu1 is not equal to mu2, and the alternative hypothesis will be mu1 less than mu2. So it will be left tail. One tail, which is left tail. Since they have asked taller than, that is, they have asked comparison to us basically. Uh, so we'll have to test that both 1% and 5% level of significance. We can substitute in this formula, which is given over here, and then we can check for the value of z. Is large sample test okay for everyone? Now we'll move to small samples. Okay, so for small samples, the sample size will be less than or equal to 30. For single mean, null hypothesis will be the same as the one we saw in large sample. Mu is not equal to mu naught, and the alternative hypothesis can be mu is equal to, oh, sorry, mu is equal to mu naught. My bad. Alternative hypothesis can be mu is not equal to mu naught. Mu is greater than mu naught, or mu is less than mu naught. Like we saw here, this will be two-tailed. These two will be one-tailed. This one will be right-tailed, and this will be left-tailed. Okay, so the value for the small samples, we'll use the T table. We won't be using a normal distribution table, which we use for large samples. We'll be using T table here. And then for this, the T table will be given to us. This will be given to us in our exams. This is the degree of freedom. This is the degree of freedom value, that is n minus 1. Like we saw before, we have to find the degree of freedom for this. And then we'll, if our question is two-tailed testing, then we'll have to check from the bottom. If it is one-tailed question, then we'll have to check from the, if it's two-tailed, we'll have to check from the top. And if it is one-tailed, we'll have to check from the bottom. The level of significance is given here. So the level of significance for each thing is given here. So this is basically, this will be 0.1% significant. This will be 1% level of significance, 2% level of significance, 5% level of significance, 10% level of significance, and 20% level of significance. And then the degree of freedom values will be given here. If it's greater than or equal to 30, suppose if our degree of freedom is 31 or 32, then we will have to use this row only. This row alone. And then similarly, here also the level of significance is given. So this will be 10%. This will be 5%. This will be 2.5%, 1%, 0.5% and 0.05% level of significance. Okay. So this will be given in our exam. The T table will be given in our exam. Tracking it will be the same as it is in a normal distribution curve. I'll show it in an example now. So the formula for Sindel mean is this: T is equal to x bar minus mu by s by root 10, where S can be written as sigma x1 minus x bar the whole square by n minus 1. Or if the value of S, this will be sample mean, population mean, and this will be sample size. Suppose if the value of S, that is the standard deviation, is given to us directly, then we can use this formula. The rest of the parameters will be same. This will represent sample mean, population mean, and then this is degree of freedom, which is equal to n minus 1. And then in case of difference of means, we'll have two samples or samples from two different populations. So for this null hypothesis is mu1 is equal to mu2. For this, the null hypothesis here in the last case, we saw null hypothesis to be mu is equal to mu naught. Here it will be the null hypothesis will be mu1 is equal to mu2. And then the alternative hypothesis can be mu1 is not equal to mu2, two-tailed. Mu1 is less than mu2. Sorry. Mu1 is greater than mu2. These two will be one-tailed. Like we saw for large sample, this will be left-tailed and this will be right-tailed. So the value of T here will be T is equal to x1 bar minus x2 bar divided by s into root of 1 by n1 plus 1 by n2. So the value of s will be this is s square, that is this is variance. Be careful with this is variance. We need only standard deviation. S is equal to root of n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. If the population standard deviation is not given and they have given us only the standard sample deviations, s1 and s2, and then if they have only given us HI, they didn't give us the sample mean, means we can find it using the normal formula sigma HI divided by n, where n is the sample size. So far, is it okay for everyone? We'll move on to questions. Okay, sorry, I didn't see. I think it is root 10. It is given in 1 minute. I'll check again. Okay, so okay, my bad. It is root n minus 1. Sorry, my bad. I wrote it incorrectly. Thank you. It is root of n minus 1. It is given n minus 1. 1 minute, I'll check it. No. So root of n minus 1 will be for the case when the standard deviation is given directly. If the standard deviation is not given directly, and then we have to find the sample standard deviation. We have to find the standard deviation using this formula. Then it will be root 10. If the standard deviation is not given, then it will be, sorry, if the standard deviation is not given, and then we will have to find it using HI, then it will be root of n. If the standard deviation is given directly, population standard deviation, if sample standard deviation is given directly, then we will have to find, then we'll use root of n minus 1. Is it okay? No problem. Uh, any other doubts? If not, we'll move on to sums and then we can close this chapter. So I'll take it as we can move on. Okay. Mhm. That that was clear, right? Is there any doubt in that n and n minus 1? I'll take it as no doubts. Okay. So for single mean and then for uh, t-test for difference in mean. Mhm. Okay. So like I said, formulas are over here. For single mean, mm, okay. So this is a large sample. Um, yes, that was for large sample. For small sample, for small sample, the value of t will be h bar minus mu divided by s by root 10 if population standard deviation is not given. This is called as population standard deviation estimate. Population uh, standard deviation estimate, which is equal to root of sigma xi minus x bar the whole square by n. The normal formula for divided by n minus 1, which is the normal formula for standard deviation. In case if the standard deviation is given to us directly, then the formula will be x bar minus mu by small s by root of n minus 1. Here degree of freedom is n minus 1. And then the confidence limit, that is the same as before. Confidence limit, here the value will be t value instead of z value. T value at the level of, at the given level of significance. This will be sample mean, this will be sample standard, this will be population standard deviation, and this will be sample size. Okay. So another small change in this is that here instead of n, we'll have n minus 1. That is the degree of freedom here. So the confidence limit will be x bar plus or minus 1 into t at the given level of significance divided by s. S by root of n minus 1. So we'll move on to sums. So the first sum is given here. Certain n is equal to 12. The data is given here. And then we have to conclude that if the injection is generally accompanied by increase in pressure, blood pressure. So we'll increase means the value, it is a one tail test. And since there is an increase, it will be like right tail. Since I have written all the data here, how since mu naught is not given to us, how do we find mu naught from here? They have asked us, can it be concluded the injection will be in general accompanied by an increase? So our hypothesis will be that there is no increase. That is, the mu should not change. If there is no increase, then the blood pressure for everyone will be the same. So mu is equal to mu naught will be such that mu is equal to 0. Since there is no increase, the level of increase will be 0 here. Or if since they have asked us accompanied by an increase, we will say that yes, there is an increase. So mu will be greater than mu naught. So mu will be greater than 0. We have written our hypothesis over here. Since there is an increase here, that it will be one tail right tail. Alpha is given to be 5%. We have the data given here. So from this we can find the mean and standard deviation. The formula for mean will be this, and the formula for sigma hi by n, and the formula for standard deviation will be root of summation hi minus h bar the whole square by n minus 1. So the value of x bar and mean is given here. Substitute it in this formula, and then we'll get the value of t to be this. T is equal to 2.8976. Uh, for 5% level of significance, degree of freedom is 11. How do we check the how do we check the t value for 5% level of significance? So we'll go to the t table. Degree of freedom is 11, 5% level of significance, and one tail. So since this is one tail, we'll have to check from the bottom. 5% level of significance is over here. Degree of freedom is 11 is over here. So the value of t will be 1.796. The value of t will be 1.796. Since the value of t is 2.8976 lies in this area, that is, it does not lie in the area of acceptance, we will have to reject H0 and accept H1. That is, there was a significant increase in the blood pressure while using that vaccine. So for the second case, for the sixth question. So for sixth question, given a sample mean of 83, x bar is given to us, a sample standard deviation of 125, s is given to us, and then a sample size of 22, n is given to us. The test the hypothesis that the values of population mean is 70 against the alternative hypothesis that it is more than 70. So more than 70. They have given us the hypothesis directly. So here H naught is mu is equal to 70. That is mu naught. Mu naught is 70 over here. Mu population mean is 70. So mu naught. And then the alternative hypothesis is that mu is greater than 70. They have asked us to use 0.025 significance level. That is 2.5% of significance level. Everything is given directly. Since it is greater than, we'll have to use one tail, that is right tail. we'll substitute in the formula T is equal to x bar minus mu divided by x bar minus mu divided by s by root of n minus 1. So everything is given to us directly. Just substitute in this formula and then we'll get the value of s to be, I will get the value of t to be 4.7659. And then the degree of freedom will be n minus 1, which will be 21 over here. We'll go to the t table with degree of freedom as 21 and 2.5% of significance in one tail. We'll set the t table value here. 2.5%, 21 degree of freedom. So 2.080. T will be 2.080. And then the value of T here is 4.7659, which is greater than the value which does not lie in the area of acceptance, basically. So we'll have to reject H0 and accept H1. So here accepting H1 means that that is the population mean is more than 70. So the 10th question is we'll have to find the confidence level. So n is given to be 7 and then population mean is given to be this 977.51. Population mean is given to be this. Standard deviation is given to be 4.42. So we'll have to find confidence level for 5%. So the question is already given here, and then this is the formula for confidence level. Just substitute in this formula and then we can get the answer. So for this cases we will have to use generally the two tail test. That is, we won't go from one tail, we'll look at two tail. So at 0.05% for two tail, for 6 the value will be, sorry, I put a wrong value here. Actually the value will be 2.447. Should be 2.447. 2.447. And then when you solve this, you'll get two values of mean. So in conclusion, we can write it as if mu lies between this value, then then we can accept h naught. If mu is in this value, else we'll have to reject h naught. So I'll tell for other sums. You can try it out on your own. Okay, so for the second question, n is given to be 10, and then the data is given here. So we are assuming that the population mean is 100. That is mu is equal to 100. And we'll have to find a reasonable range. So here reasonable range means confidence level. So we'll have to find the confidence level. Since the level of significance is not given to us directly, we'll assume it to be 5%. Here also the level of significance was not given to us directly in first question, so we assumed it to be 5%. Since they did not ask us if there is any increase or decrease as such in the second question, so our hypothesis will be mu is not equal to mu naught. Mu alternative hypothesis, sorry, mu is equal to mu naught will be your null hypothesis, and mu is not equal to mu naught will be your alternative hypothesis. Since so this will use the two tail test, and then the value of t will be for 5% level of significance with degree of freedom will be 10 minus 1 is equal to 9. So for 9 at 5% level of significance, the degree of freedom will be 2.362. This is 3. 2.362. So in the bell curve, dot If the value of t lies in this range, so if the value of t lies in 2.362 minus 2.362, if the value of t after we calculate lies in this range, then we can accept H naught, else we have to reject H naught. So for third question, a mechanist is making engine parts with an axle diameter of 0.07 inch, a random sample of 10 parts, n is equal to 10, shows a mean diameter. X bar is equal to 0.472. Sorry, I forgot to mark this. This is a population mean mu, and a standard deviation of 0.04 inch. Small s is also given. Computer statistics you use to whether the word is meeting the specifications. So they didn't ask us if there is any less than or greater than and so on. So it will be, and the level of significance is not given. So first level of significance will be 5%, and H naught will be mu is equal to mu naught. H1 will be mu is not equal to mu naught. Two-tailed, we can substitute in the formula T is equal to x bar minus mu s by root of n minus 1, and then we can compute the value of T, and then check if it lies in the area of acceptance or not. So for the fourth question, n is equal to 12, degree of freedom will be 11, and the weights are given here. Taken, this is mu is given to be 0.5 kg, and then they do not give us the sample mean or sample standard deviation. Alpha we can take it as 5% since they didn't give to us. So we will have to use the formula T is equal to x bar minus mu by capital S by root 10, where S will be sigma summation of xi minus x bar the whole square by n minus 1. And then to find the mean, you can use the formula xi by n, summation xi by n. So they did not ask us if there is any greater than, less than, or such. So h naught can be taken as mu is equal to mu naught, and h1 can be mu is not equal to mu naught, two-tailed. Okay, so for fifth question, the mean weekly sales of soap bar in departmental store. Okay, this is mu is given here, and then n is given here. For typical wheat increase to, okay, so x bar is given to us, the sample mean is given to us, x bar is given to us, and standard deviation cap small s is given to us. We'll have to check if there is an increase, because the advertising campaign successful means increase basically. So we'll have to check h naught will be mu is not equal to mu naught, h1 will be mu is greater than mu naught, one tail, right, right tail, and level of significance is 5%. Since everything is given to us, we can substitute in this formula and we can get the value of t. For the seventh question, new soap manufacturing department were distributing a brand to many retail shops. Before the heavy advertising campaign, the mean sales per shop population mean is given to us. Then campaign sample is given to us, and then the mean sales was found out to be sample mean is given to us. Standard deviation small s is also given to us. From this, at 5% level of significance, we have to find if the advertisement was effective. They did not ask us if that's an increase or decrease, just effective. So if there is any change in the sales or not, so it will be two tailed. So it will be alternative hypothesis will be mu is not equal to mu naught. uh, Null hypothesis will be mu is equal to mu naught, two tailed. And then for 8th question, machine is producing searching process for average thickness. Mu is given to be this, and then n is equal to 10, sample size is equal to 10, and then average thickness of 0.024 centimeter. Sample mean is given to be 0.024 centimeter, and then sample standard deviation is also given. Test for significance of the deviation. They didn't ask us if there is any increase or decrease as such, just change in it. So H1 alternative hypothesis will be mu is not equal to mu naught. So it will be two tailed, 5% level of significance. And then for the ninth question, they have asked us heights of 10 children. N is equal to 10. Selected at random from a given locality with mean. Mu sample population mean is given to be 63.2, and variance is also given. Sorry. This is the sample 63.2. Since it talks about only the 10 children, that is the sample of 10 children. So it is mean is 63.2, and variance is 6.25 centimeters. That is yes. A smallest square is given. We need to find yes. So root of 6.25, which will be equal to 2.5. It will only be positive since standard deviation can only be positive. At 5% level of significance, we have to change, we have to check if the children at a given locality are on the average less than 65 centimeter. That is, mu is given to us, population mean is given to us. Our null hypothesis will be mu is less than 65. So it will be one-tailed, left tail to be precise. Everything else is given to us. We have to substitute in the formula, and then we have to substitute in the formula h bar minus mu s small s by root of n minus 1, and then we'll have to check for left tail test, and then we'll have to take the value of t and then check with the left tail test. Is single mean okay for everyone? We'll move on to difference of mean, and then we can close. Okay. And for a small sample test, don't forget to check the value of t using uh, degree of freedom, that is n minus 1. If you take it using n, your value may be wrong, and then you may get the wrong answer. So this is for large sample. Difference of mean, we'll see the formulas, and then I have one question for this. Yep, I have one question for this. Difference of mean, value of t will be x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. Then sigma 1 and sigma 2 are given and not equal. This is sample 1 mean. This is sample 2 mean, and then this will be population mean 1. Population standard deviation 1, population 2 standard deviation, and then size of sample 1, sample size 1, sample size 2. In case of z, if sigma 1 is equal to sigma 2, we can take the sigma 1 outside, which will be equal to sigma, and then we can take this formula. It should be t of sigma. So, this is for large sample. Difference of mean, value of t will be x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. Then sigma 1 and sigma 2 are given and not equal. Similarly, if sigma 1 and sigma 2 are not given and only uh, sam- sample standard deviation is given, sample standard deviation for body samples are given, then we'll have to use this formula where S will be equal to root of n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. Here the degree of freedom will be n1 plus n2 minus 2. Many people may miss out on this too. Please make sure you don't miss it out. Okay, for third question, two salesmen A or B are working in a certain district. We can keep A as the sample 1 and B as the sample 2. From a sample survey conducted by the head office, the following results were obtained. State whether is there any significant difference in the average sales between two salesmen. So they have asked only significance decrease, not increase or decrease. So our alternative hypothesis will be mu1 is not equal to mu2. Since this is difference in mean. The data is given here. I have written the data here and then I made the hypothesis to h naught is equal to mu1 is equal to mu2. H1 will be mu1 is not equal to mu2. So it will be two tail. Since they didn't give us the value of sigma, that is population standard deviation, we'll have to find the value. We'll have to use this formula. And then using this, we substituting everything in these two formulas, we get the value of t to be this. And degree of freedom will be 36 over here. Since the degree of freedom is greater than or equal to 30, like I said before, we will have to use this, right? Since it is given as greater than or equal to 30. So here the degree of significance will be at they didn't give us the they didn't give us the level of significance, so we can take it as 5%. Degree of freedom is given to be 36. That is, we are getting it greater than or equal to 30. At 5% in two tail, we get the value to be 1.960. Since t does not lie between minus 1.960 to plus 1.960, we'll have to reject h naught. And then we'll see for other questions. Okay. So sample of two types of electric light bulbs were tested and a lens are given. So N1 is given, everything is given with notations here. Is the difference in mean sufficient to warrant that type 1 is superior to type 2? So they are asking our hypothesis will be mu1 is greater than mu2. Since superior or since superior, it is like greater than type 1 is greater than type 2, we'll have to assume our alternative hypothesis to be mu1 is greater than mu2. It will be right tail, one tail. And then the second question, the average number of articles produced by two machines per day. N1 is given to us, and then the average, sorry, H1 bar. This is the average. H1 bar is given to us, H2 bar is given to us, standard deviation as S1 and S2, respectively, based on records of 25 days of production. So sample size, that is number of days, is the sample size for us. So N1 is equal to N2 is equal to 25. Can you read out both the machines to be equally efficient at 1% level of significance? Alpha is equal to 1%. We'll have to check if mu1 is equal to mu2. Alternative hypothesis will be mu, or the original hypothesis will be, null hypothesis will be mu1 is equal to mu2. Alternative hypothesis will be mu1 is not equal to mu2. Since we are just checking if it's not equal, this will be two tail test with degree of freedom as 20 plus 25, degree of freedom as 43, n1 plus n2 minus 2. since it is greater than or equal to 30 in two-tailed test, we can use the t table and find the value of t. If the value of t after substituting in the given formula, which will be t is equal to x1 bar minus x2 bar divided by s by root of s square root of 1 by n1 plus 1 by n2. S will be equal to root of s1 square n1 plus s2 square n2 by n1 plus n2. Substitute in these formulas and then you'll get the value of t, based on which we can, if the value of t lies in the area of acceptance, you can accept it, else you can reject. For fourth question, the data is given to us. Let us consider this to be n1 and this first sample and this to be the second sample. So x1 bar, x2 bar, n1, n2, and then s1, s2 is given to us. Alpha is equal to 5%, 0.5% level of significance is given to us. Uh, Alpha is equal to 5%, and then we'll have to check if the sensitivity achieved by formal program is significantly higher than the sensitivity achieved by informal program. Significantly higher. So one-tailed, our alternative hypothesis will be mu1 greater than mu2. So it will be right-tailed. We can substitute in this formula itself and get the value of t, and then we can check accordingly. So for fifth question, mean life of a sample of 10 electric bulbs was found to be x1 bar n1 standard deviation s1 is given, and for second thing n2 showed a mean life of x2 bar is given to us, and then standard deviation s2 is given to us. The significant difference between two. So they are just asking if there is any difference. The level of significance will be 5%. Degree of freedom will be here. Degree of freedom will be, for the previous question, degree of freedom will be 25. Here the degree of freedom will be same 25, because 10 plus 17 minus 2, and then from this we'll have to check if there is any significant difference. So our alternative hypothesis will be mu1 is not equal to mu2. So two-tailed test. And then the next question is given to us. In this is first sample, second sample, n1, n2, and then x1 bar, x2 bar is given to us, and then variance is given to us, that is s1 square and s2 square. We have to take the square root of these two, that is 11, and 12 will be our s1 and s2. They have asked any significant differences there, so we'll have to take H alternative hypothesis will be mu1 is not equal to mu2, two-tailed, with degree of freedom as 15. We can use it, and then value of significance will be 5%, since nothing is mentioned over here. And then the next question, sample size is given to us, n1, n2 is given to us, h1 bar, h2 bar is given to us. Sum of squares of the deviation from the mean are sum of squares. Okay, So standard deviation is given to us. Sorry, standard S1 square and S2 square is given to us. Mm, S1 square and S2 square is given to us. From this, we can find S1 and S2 by taking its square root, and then we will have to see if it is drawn from the same normal population. That is, H1 will be mu1 is not equal to mu2, alternative hypothesis. So two-tailed test. 5% level of significance. Since level of significance is not given, degree of freedom will be 9 plus 7 minus 2, which will be 14. 8 question to verify whether a process accounting improved performance and similar test was okay. So improved. So it means that if there is any increase, that is alternative hypothesis will be mu1 greater than mu2. Where first will be before the test. Sorry, there is any increase. So first will be mu1 is equal to mu2. Second will be if there is any, if we take the first sample to be before and the second sample to be after, then it should be that mu1 is less than mu2. If we take the second sample to be before and the first sample to be after, then our alternative hypothesis will be mu1 greater than mu2 when the first sample is after and the second sample is before. Since we are taking it as first sample to be before and second sample to be after, it will be like this. Two tailed, sorry, one tailed, one tailed, and then since mu1 less than mu2, it will be left tail. Okay, so we know n over here, and then from this we have to find h1 bar, h2 bar, s1 and s2. How can we find this? H1 I will be summation, h1 bar will be summation h1 I by n1, and then S1 will be summation, square root of summation h1 I minus h1 bar by root of n. So n1. From this we can find the sample standard deviation for the first set. Similarly, we can find it for the second set, and then we can use this formula h1 bar minus h2 bar by s into root of 1 by n1 plus 1 by n2, where s will be root of n1 square s1 plus n2 square s2 by n1 plus n2 minus 2. Degree of freedom here will be 12 plus 2 minus 2, 22. And then similarly, uh, okay. So for the next question, the incomes are given for sample 1, and then for the sample 2, the incomes are given. From this, we can find N1 and N2. That is, N1 here is N1 is sits here, and then for sample 2, N2 is N2 is equal to 9. From this, like I said, using these formulas, we can find x1 bar and sample standard deviation also. From this, we can find the value of t and t using these formulas. Using the formula given below, yeah, using these formulas, you can find it. And then discuss the validity of suggestion that the industry one pays labors more than the industry two. So they have asked us pays more, pays much better. That is, mu one is greater than mu two. If we consider the mu one to be the first sample and the first industry, and mu two, if we consider industry one to be the first sample and industry two to be the second sample. Since this is alternative hypothesis, we will use one-tailed, right? So that's all. Is it okay? Is it okay for you? Where? In which expression? If alpha is not given, then it is considered to be as 5%. If level of significance is not specified to us, then it is always considered to be as 5%. If level of significance is given to us, then we have to take that level of significance. I'm sorry, I forgot to mention it in some cases. Is it okay? Okay. Okay, so they are not